Good morning. Today I am going to discuss about oxidizing agents. What do you mean by oxidation? It is addition of oxygen or removal of hydrogen or loss of electrons. Oxidizing agents helps oxidation and itself undergoes reduction. What are the different types of oxidizing agents? Oxygen itself an oxidizing agent, ozone, hydrogen peroxide, selenium dioxide, chromium oxidants, manganese oxidants, DDQ, paracids, osmium tetroxide, lithium tetracetate, NBS, etc. are different types of oxidizing agents in which today I am discuss about selenium dioxide. The oxidation using selenium dioxide is called Rayleigh oxidation. And what is the structure of selenium dioxide? SeO2. Here SE plus 4 oxidation state plus 4 oxidation state, and selenium oxide is a white crystalline substance. How can you prepare selenium dioxide? On oxidizing selenium we get selenium dioxide. What are the solvents used in selenium dioxide oxidation? Benzene, toluene, xylene, chlorobenzene, ethers, methanol, ethanol, water, acetic acid, etc. What are the applications of selenium dioxide oxidation? One of the application of selenium dioxide oxidation is oxidation of alpha position of electron withdrawing substituent. Here, most preferred electron withdrawing substituent is carbonyl group. In general, we can write RCH2W. Here, W represents an electron withdrawing group. In the presence of selenium dioxide, alpha position of the electron withdrawing group, that is the CH2 group, will get oxidized into C double bond O, and the resultant product will be RC double bond O W. Here W is the electron withdrawing substituent. For example, CH3CHO. Here withdrawing substituent is CHO. Undergoes Rayleigh oxidation. What will be the product? Alpha position of the electron withdrawing substituent, that is CH3 group, getting oxidized into aldehyde. CHO, CHO. Another example, PHCH2CHO. On Rayleigh oxidation, we get PH C double bond O CHO. Another example, CH3 C double bond O CH2 CH3. Here, this carbon is an alpha carbon and this carbon is also an alpha carbon. So, what alpha carbon will be oxidized? The more substituted carbon will undergo oxidation provided with the 2 minimum hydrogen. That will undergo Rayleigh oxidation more preferred than the less substituted carbon. So, in these two alpha carbon, which is more substituted carbon? Obviously, more substituted carbon is the CH2 carbon, not CH3 carbon. So, CH2 carbon will get oxidized into C double bond O, and the final product will be CH3 C double bond O C double bond O CH3. That will be the major product. And of course, minor product will also form, that is CHO C double bond O CH2 CH3. That is the less substituted carbon getting oxidized. That will be the minor products. What is the mechanism of selenium dioxide oxidation? Selenium dioxide in the presence of water converted into H2SeO3, serenous acid. This is the structure of serenous acid. Sc double bond O OH OH. This is the real oxidizing agent. Then what is the mechanism? This is a compound having electron withdrawing substituent Rc double bond O CH2 R, and this is a keto group. Keto functional group tautomerized into enol. This is the structure of enol. RCOH double bond CH R. This is enol. Keto enol tautomerization. When this enol reacts with the oxidizing agent Sc double bond OOH OH, that is our serenous acid, one molecule of water getting eliminated. This is OH and this hydrogen, and in total H2O getting eliminated, and this bond will shift to carbon to oxygen bond, and single bond converted into double bond, and this double bond will attach to oxygen, and this double bond will shift to selenium. Then what will be the product? R C double bond O single bond CH R connected to oxygen connected to single bond selenium OH, and here one molecule of water getting eliminated, and this intermediate eliminates one molecule of water and selenium getting precipitated as black precipitate. Here this bond will shift to carbon to single bond oxygen and converted into C double bond O, and this bond breaks to selenium and OH group getting eliminated. In total H2O getting eliminated and selenium precipitated as black precipitate. Oxidation state is 0, and our keto group converted into 1,2 dicarbonyl compound RC double bond O C double bond O R. What are the examples of ninhydride selenium dioxide oxidation? Here alpha position getting oxidized. This is the alpha position. CH3 getting oxidized into CHO, and this is also an alpha position, but it has only one hydrogen. So this carbon getting oxidized into CHO functional group. And what is the case of this compound? We get 1,2 dicarbonyl compound, and it is symmetric molecule, so there is no position, no problem in the case of alpha position. Then what is the case of this compound? On Rayleigh oxidation, it will converted into this compound, and on hydrolysis, this compound is highly reactive due to the presence of 3 C double bond O functional group, and in the presence of water it get converted into this compound. This is our ninhydrine used in organic practical of paper chromatography as a spraying agent. Another application is oxidation of allylic position to alcohol. That is CH2, CH2R. On Rayleigh oxidation, its allylic position. This is the allylic position. Allylic position getting oxidized into alcohol, and we get allylic alcohol. If allylic position is highly reactive, then alcohol may oxidize to carbonyl compound. That is, further oxidation may occur. It is the one of the best method to convert olefin to alcohol. For example, this is a hexene, cyclohexene. On Rayleigh oxidation, it will converted into alcohol. Then allylic oxidation follows set of rules. What are the rules? First one, if olefins are alkyl substituted, then alpha position of highly alkylated sp2 hybridized carbon preferentially undergoes oxidation. That is C double bond C CH3 hydrogen CH3 CH3. First rule postulates that highly alkylated sp2 hybridized carbon. This is the highly alkylated sp2 hybridized carbon. This carbon getting preferentially undergoes oxidation, which means either this CH3 group or this CH3 group getting oxidized into alcohol, and this is our allylic position. This is allylic position, and this is allylic position, and this is also allylic position, in which most substituted sp2 carbon, that is this carbon, undergoes oxidation. Second rule, at olefin, if primary, secondary, tertiary allylic position present, reactivity order with respect to selenium oxidation will be secondary greater than primary greater than tertiary. For example, C double bond C, hydrogen, hydrogen, CH2, CH3, CH3. Both sp2 carbons are similarly substituted, and here this alpha carbon is CH3, that is primary, and this is CH2 CH3. This is CH3 whereas this is CH2. Then which carbon will get oxidized? Of course, CH2 will get oxidized into alcohol. Then third rule, if first and second rule are in contrary, first rule will be preferred. For example, consider CH3, CH3, double bond, hydrogen, CH2, CH3. In this case, this carbon is substituted by 2 CH3 group and here one CH2 CH3 group. Then which carbon allylic position will get oxidized? According to first rule, this carbon getting oxidized, and according to second rule, this second CH2 group getting oxidized. So first and second rule are in contrary. Then in such cases, first rule is preferred. That is, this carbon getting oxidized, not this carbon. This allylic position will get oxidized. Then fourth rule, if there is a possibility for formation of E or Z, endogen or Zusammen product, E product will be preferred. E product will be preferred. For example, in this case, we can say this carbon will get oxidized, and here these two CH3 groups, which CH3 group will get oxidized? Then according to fourth rule, E product will be preferred. So this CH3 group will get oxidized into alcohol. Then only we get E products. What is the mechanism of this oxidation of allylic position to alcohol? In the first step, selenium oxide reacts with water to form the real oxidizing agent H2SeO3. This is the structure of H2SeO3 when reacts with the allylic alkene. This oxygen will attack hydrogen and this bond will shift to this bond and double bond will attack selenium. This is a very familiar reaction to you, that is an ene reaction. We already studied in the pericyclic reaction, that is ene reaction. Group transfer reaction, hydrogen atom transferred to this oxygen, and this bond will shift to this, and this double bond will shift to selenium, and we will get this product, and which eliminates one molecule of water, and we get CH2 double bond CH2 selenium double bond OH. Then this oxygen lone pair of electrons, this double bond will oxygen will attach to this double bond, and this double bond will shift to this bond, and this bond will cleaved into selenium. That is, this bond is cleaved, and here single bond changed into double bond, this double bond changed into single bond, and this connected to oxygen, and which is connected to selenium. Single bond, double bond changes to single bond, and selenium connected to OH. This is the structure. Here double bond used to bond with this carbon, and we get this product. Finally, it eliminates selenium oxide. This bond will shift to selenium, and selenium converted into selenium double bond O, and this bond breaks to oxygen and converted into O minus, and hydrogen getting protonated into O minus and convert into OH. This is our allylic alcohol. So here two important reactions take place. One is in reaction, another one is sigma-tropic rearrangement reaction, that is 2,3 sigma-tropic rearrangement reaction. So this mechanism is a combination of two pericyclic reaction. One is in reaction, another one is 2,3 sigma-tropic rearrangement reaction.